Now see the next question which is given to us. We are given argon with atomic number 18, mass number 39. Atomic number of argon is 18. It means protons are 18 and number of electrons are also 18. Number of neutrons is equal to A minus Z. Mass number of argon is 39. So 39 minus 18 is equal to 21. 39 minus 18 is equal to 21. So how many neutrons are present in argon? There are 21 neutrons. So we write these number of neutrons and protons in the nucleus. Atomic number is 18. So in the nucleus of argon we have 18 protons and we have 21 neutrons. Now atomic number of argon is 18. So it means argon has 18 electrons. We distribute these 18 electrons in different shells. In K shell 2 electrons, L 8, M 8 electrons. Now we write these number of electrons in different shells of Bohr's model of argon. We write 2 electrons in the first shell, in the K shell 2 electrons, in the L 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8. M shell also has 8 electrons. M is the third shell. We write 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. I hope this question is clear to you. See the next question which is given. Draw Bohr's model for the following atoms indicating the location of protons, electrons and neutrons. Draw Bohr's model for the following atoms indicating the location of electrons, protons and neutrons. The first element which is given is potassium. Potassium, atomic number 19, mass number 39. With the help of atomic number and mass number, we will write the number of protons, electrons and neutrons, and then we will draw the Bohr's model for potassium. So atomic number of potassium is 19. It means number of protons for potassium. Potassium atomic number 19. So number of protons are 19. Number of electrons must be equal to the number of proton. Since atom is a neutral particle, so number of electrons are also 19. Number of neutrons, we can calculate number of neutrons by using the formula A minus Z. A is mass number while Z is atomic number. What is the mass number of potassium? 39. Atomic number 19. By subtracting 19 from 39, we get the answer, that is 20. So how many neutrons are present in potassium? We have 20 neutrons. So we write number of inside the nucleus, we write 19 protons and 20 neutrons. So in this way we write number of protons and neutrons inside the nucleus. Now we will write the number of electrons and we distribute number of electrons in different shells. We know the capacity of K is 2 electrons, L can accommodate 8 electrons and in M there are 8 electrons. N can have 8 electrons. Atomic number of potassium is 19. It means potassium has 19 electrons. So we distribute these 19 electrons in different shells. K has 2 electrons. In L shell there are 8 electrons. In M 8 electrons and N has 1 electron. Now we write these electrons in different shells of potassium atom. In the first shell, that is K shell, we write 2 electrons. Second shell L has 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. M also has 8 electrons. So we write 8 electrons in M. 1, 2, 3, 4, 5, 6, 7, 8. N shell has 1 electron. So we write 1 electron in N shell. I hope Bohr models of potassium is clear. Now see the next question. Next we are given silicon. Silicon, atomic number 14, mass number 28. With the help of atomic number and mass number, we will write the number of protons, electrons and neutrons, and then we will complete the Bohr models for silicon. Atomic number of silicon is 14, so it means there are 14 protons as well as there are 14 electrons. Number of neutrons is equal to A minus Z. What is the mass number of silicon? 28. Atomic number 14. 28 minus 14 is equal to 14. So how many neutrons are present in silicon? In silicon we have 14 neutrons. Now we write number of protons in the nucleus. In the nucleus we have 14 protons and 14 neutrons. How many electrons are present in silicon? Atomic number is 14, so it has 14 electrons. We distribute these 14 electrons in different shells. In K shell there are 2 electrons. Out of 14, 2 electrons are present in K shell. 8 electrons are present in L. And remaining 4 electrons, they are present in M shell. Now we write these electrons in different shells of Bohr's model of silicon. We write 2 electrons in K shell, 1, 2, 8 electrons in M, 1, 2, 3, 4, 5, 6, 7, 8 and 4 electrons in M shell, 1, 2, 3, 4. I hope Bohr models of silicon is clear to you. Now see the next question. Argon is given to us. Now see the next question which is given. In the next question, we are asked to write down electronic configuration of the following elements. Some elements are given to us and we are asked to write down their electronic configuration. The first element is silicon. Silicon, atomic number 14. Atomic number 14, it means silicon has 14 electrons. So electronic configuration of silicon will be 1s2, 2s2, 2p, 6, 3s, 2, 3p, 2. I hope electronic configuration of silicon is clear. Now see the next element which is given. Next we are given magnesium. We know atomic number of magnesium is 12. It means magnesium has 12 electrons. Now we write the electronic configuration for magnesium. 1s2, 2s2, 2p, 6, 3s, 2. This is the electronic configuration for magnesium. I hope this is clear. See the next element which is given. Next is aluminium with atomic number 13. Atomic number of aluminium is 13. It means aluminium has 13 electrons. We write the electronic configuration for aluminium. 1s2, 2s, 2, 2p, 6, 3s, 2, 3p, 1. This is the electronic configuration for aluminium. The next element which is given is argon. Argon, atomic number 18. So we write the electronic configuration for argon. Distribute 18 electrons in different shells and it's in different subshells. 1s2, 2s2, 2p, 6, 3s, 2, 3p, 6. I hope this question is clear to you. Now we will see the next question which is given. The atomic number of an element is 23 and its mass number is 56. How many electrons protons and neutrons does this an element have? We are given an element with atomic number 23 and mass number 56, and we are asked to find number of electrons, protons and neutrons which are present in this element. With the help of atomic number and mass number, we will find number of electrons, protons and neutrons. So atomic number, that is Z is equal to, what is the value of Z, which is atomic number? Z is equal to 23. Atomic number means number of protons which are present in the nucleus of an atom. When Z is equal to 23, it means number of protons are 23. Since atom is a neutral particle, so it means it must contain equal number of protons and electrons. So number of electrons are also 23. Number of neutrons, how can we find number of neutrons? By using the formula A minus Z, that is mass number minus atomic number. What is the mass number of this element? The mass number is 56 and atomic number is 23. By subtracting 23 from 56, we get 33. So how many neutrons are present? The number of neutrons are 33. So in this way, we find number of protons, electrons and neutrons in this element. I hope this question is clear. Now see the next question which is given. The next question is, the atomic symbol of aluminium is written as aluminium, atomic number 13, mass number 27. What information do you get from it? Here a symbol of aluminium is given and we are asked to write the information which is obtained from this symbol. Now we will write the information. First one, usually atomic number is written as subscript and atomic mass is written as superscript. So the first information is atomic number of aluminium is 13, while atomic mass, that is Z, of aluminium is 27. Atomic number of aluminium is 13. It means number of protons are 13, number of electrons are 13, and number of neutrons is equal to A minus Z, that is 27 minus 13. 27 minus 13 is equal to 14. So how many neutrons are present in aluminium? There are 14 neutrons. I hope this question is clear. Now see the next question which is given. The next question is sodium, atomic number 11, mass number 24. It is a radioactive isotope. How many electrons, protons and... Now see the next question which is given. Sodium, atomic number 11, mass number 24, is a radioactive isotope. How many electrons, protons and neutrons are there in this isotope? With the help of atomic number and mass number, we can find out the number of electrons, protons and neutrons. Now atomic number of sodium is 11. What is the value of Z for this sodium element? Z is equal to 11 and mass number A is equal to 24. Now we know the value of atomic number as well as atomic mass. Now we can write the number of protons, electrons and neutrons. So number of protons are, atomic number is 11, so number of protons are 11. Number of electrons are also 11. Number of neutron is equal to A minus Z. What is the value of mass number? Mass number is 24 and atomic number is 11. So 24 minus 11 is equal to 13. So how many neutrons are present in sodium? Atomic number 11, mass number 24. We have 13 neutrons in this isotope of sodium. I hope this question is clear. Now see the next question which is given. The question is, how many electrons can be placed in all of the subshells if n is equal to 2. We know when n is equal to 2, it is the second shell, that is the L shell. L shell has two subshells, that is 2s and 2p. The maximum capacity of S is equal to 2 while P is equal to 6. So we can write 2 electrons in S and 6 electrons in P. So total number of electrons which can be placed in L shell is 8. We can place 8 electrons in L shell. 8 electrons. I hope this question is clear. See the next question which is given. The next question is, nitrogen has two isotopes N14 and N15. Which isotope has greater number of electrons? The first isotope is N14 and the second one is N15. We know nitrogen, atomic number of nitrogen is 7, mass number is 14 for first isotope. For second isotope, again atomic number of nitrogen is 7 but mass number is 15. We know atomic number means the number of protons which are present in the nucleus of an atom. If atomic number of nitrogen is 7, then number of protons are 7. Number of electrons must be equal to number of protons, so number of electrons are also 7 for this isotope. Similarly, for this isotope, number of protons are 7 as well as number of electrons are also 7. So it means we know isotopes are the atoms of an element which have same atomic number but they have different atomic masses. Since both the isotopes of nitrogen, they have same atomic numbers, so that's why they have same number of electrons. I hope this question is clear.